Next up, we have Kate Meredith, who is the president of GLAS Education. Kate, the floor is yours.
Thank you, Anna. Hi, everyone. My name is Kate, and I am the president and director of education at GLAS Education. That's Geneva Lake Astrophysics and STEAM. And we are just a couple of hours north of Chicago. I'm coming to you from my office, and I'm covering up the blonde paneling in the background with a beautiful picture of our former home at Yerkes Observatory. And at this point in the presentation, if we were together, I would hand you a 3D model of this observatory because it is exquisite. I am today wearing a blue shirt, necklace. I have brown hair with very distinguished patches of gray on the side, and I am Caucasian. My pronouns are she, her, hers. So a year ago, we had the honor of participating in the SciAxis conference. I brought a team with me, and we had 40 minutes to explain what we've been doing with a National Science Foundation grant over the past 3 years. So I'm going to share my screen with you. Give me one moment here. And let me present. Just one moment. I had this all worked out with my 2 screens. And now you are seeing the incorrect screen, so I'm going to stop sharing and choose a different screen. There we go. Okay, so Afterglow access is going to be the topic of my conversation this morning. Let's see, and let me see if I can get us to proceed through our thing. So the project that we were working on, Innovators Developing Accessible Tools for Astronomy, was a large National Science Foundation grant to increase accessibility to image processing or data processing software in astronomy. This slide shows a lot of logos here from the giant team that it took to get this together. Associated Universities, Turk, Logos Consulting, the University of North Carolina, Chapel Hill, and the University of Nevada at Las Vegas. And of course, we were funded by the National Science Foundation. I'll give a moment for our signer to catch up with all of that. And we are the former Yerkes Observatory programs who left the building in 2018 when the University of Chicago shut down. This is a picture of the entire staff and our dogs in front of Yerkes Observatory. And someday I would love to give everyone an accessible tour of the great refracting telescope that is at Yerkes. So we have been working to maintain our work, a mission to increase accessibility and equity in STEM fields. So what we presented on last year was our pathways to diverse participation in STEM. So we walked through the steps of invitation, participation, accessibilizing, which is our own made-up word for taking objects, educational materials that are inherently inaccessible and creating something to band-aid, to just bridge the accessibility problems. So there's a lot of cool techniques that we have borrowed and developed on our own to do that. But what I'm going to talk about today is accessible by design. So what we wanted to do was finish the process of allowing students to participate in STEM fields. So not just the products of science to be accessible, but the process of science. So that means that you need to be able to mess with the data in a way that's accessible. So the target of this grant, even though there were, on the grant that we worked on, there was a lot of educational research, and we really studied how students interacted with the materials and how they interact with coding, which is one of the strong tools for increasing accessibility. But what we have here is Afterglow Access is our target. So this is the data processing software. So when we were in previous grants, we were able to make the educational materials accessible, but we were not able to have blind and low vision students actually interact with the data and take measurements. So what we have here is a picture of the old Afterglow access, which is on a visual GUI. It also runs on Flash Player, so you see the ugly little sign that says Adobe Flash Player is no longer supported. So what we did was we got a group of blind, visually impaired, and fully sighted scientists, teachers, software engineers together to redesign this software from the ground up. And what I'm going to go through is just a few of the things that we did. So in doing this in community with the visually impaired students and astronomers, we did work with Wanda Diaz-Merced and Nick Bond on this project, along with Sienna Baram and experts from around the world in trying to make these software more accessible. So Afterglow Access now has accessibility features which were requested and designed by the target user group. And what we've really focused on is areas of navigation, which you see a picture of here, where we changed the contrasts. You have now a lot of different ways and the ability to see more easily those the content on the screen. And the ease of navigation also allows you to change the themes. One of the things that makes this software very accessible is it's online. You don't have to have special software to run it. You don't have to download anything. It's right there. It's all done server side. You don't have to worry about the strength of your computer in order to handle scientifically sophisticated data. So on this image, you can see the Afterglow Access site is now in a different theme. These themes are definable in quite a bit of detail, and the software remembers what you preferred from one session to the next. And so when you come in, all of your accessibility preferences are remembered for you. There are 3 different panes that you generally work in. Your library of images, which are all screen reader accessible, so you can choose which images you want to work with. The visual data screen, which we can zoom in on, click in and out with keyboard commands in order for zoom text not to get lost, and then the tools section on the far right. All of these areas are able to be navigated by the user very easily. So customizable themes, as I said, were one of the areas that we worked in. You see here an example of the different types of customizable themes that you can work with. You can edit your theme, you choose your color, you can choose the font weight and the font size. So any combination of those can be used for you. And then the last area that we worked in was discoverability. In user-centered design, we want students to be able to discover on their own intuitively how a piece of software works. So with just a few keyboard commands, you're able to zoom in or focus your attention on particular areas of the software. And this was a very important part of the software design. And if I was able to give you a full tour of this software, which I'm happy to do at some other time or in some other venue, but these are all I want you to do is understand today that we've built a lot of features into this software by user request to make navigation much easier. Now, the last thing that we were working on toward the end of the project, for which we're looking for additional funding for, is to work on the Sonification Tool. To my knowledge, this is the first Sonification tool that is able to scan a special file data that's used in astronomy. So this file, even though we display it visually, typically for sighted people, it is simply numbers on a spreadsheet. So what our software does is scan this from the bottom of the image to the top. From left to right, you play low tones to higher tones. The tones are weighted depending upon the amount of energy that has been recorded for each one of those little boxes. And then you are able to scan from bottom to top. We also have some diffuse background sounds that communicate nebulosity or cloudiness of the image. And what students can do also is auditorially zoom in on different sections. So I would scan from the bottom to the top of this image. Oh, I heard something interesting in the top right. So I can navigate with keyboard commands to the top right, and I've essentially zoomed in Sonification. Well, like I said, this tool is very new in, this tool is very young. And there's a lot of research that needs to be done with the users on this, asking questions about, does it meet the goal of communicating scientific data in a sonified form? Are students actually able to choose their images, analyze the data, extract information, and draw conclusions without the assistance of a fully sighted person? That is our goal. I'm happy to talk to you more about this at any time. And yeah, it's just really exciting work, and I enjoy being here. So if you have any questions, that's a brief overview of what the software is designed to do, and where we're going with it in the future.
Amazing. Thank you so much, Kate.